This is Facility Science Podcast number 10. I am Jason Doolittle, and today I'm talking about maintenance planning and scheduling. And these are two separate things that are like an organizational superpower when they're combined effectively. So we'll start with defining what these things are. So maintenance planning is a process of answering the following questions. Those are what needs to be done, how should it be done, and what is needed in order to do it. Maintenance scheduling is the process of answering the following questions, which are when does it need to be done and who should do it. So what are we trying to do with this? One of the things we're trying to do is optimize our maintenance budget. Another thing we're trying to do is increase wrench time, or another way to say that is to improve the utilization of our maintenance personnel. And if you think about what percentage of your maintenance technician hours are spent doing actual maintenance work versus other activities, like looking for information, manuals, standards, drawings, gathering parts, gathering tools or other materials, driving back and forth, a tour from the job site to the shop or the supply house, or even tracking down the last guy that did this repair to ask what they did. And if we can optimize this, our cost per repair goes down since the ratio of productive hours to non-productive hours goes up. We can complete more work in a given day or week or month, since every technician can now complete more tasks per day or week or month. And this helps to manage your backlog of maintenance tasks and also reduce reactive maintenance because you're getting more of the backlog done, and also to optimize the size of your maintenance workforce. Another thing we're trying to do here is reduce unplanned downtime. Another way to say this is we want to maximize uptime by getting the maintenance done as efficiently as possible and at the right time. The other thing we're trying to do is optimize our spare parts and material stock. So this process will help us figure out what parts and materials we will need, how many we will need, and also when we will need them, which is good information to have. Because we want to try to avoid having a bunch of unused, or even worse, unusable stock just sitting around. It's a waste of money and space. We want sort of just the right amount of stock at the right time. And we also want to avoid the opposite thing, which is to constantly have to wait on lead times or long shipping times, or to pay for expedited shipping for parts that we should have known we would need ahead of time. And then another thing we can do with this is improve morale, and that's both of the maintenance staff and the operations staff. So the maintenance staff wants to feel like they're in control of the maintenance situation and that they have logistical and informational support, rather than being in a situation where they're constantly fighting fires and having to figure out everything that needs to be acquired or done in the moment while the fire's burning. And then the people using the buildings and equipment, the operations personnel, they want to know that their workplace is being properly cared for and that their maintenance concerns will be addressed in some sort of reasonable, systematic way. Okay, we'll get into maintenance planning. So maintenance planning, before any work is done or even scheduled, needs to be planned. And like I said before, that's figuring out what needs to be done, how should it be done, and what is needed in order to do it. First, we'll talk about what needs to be done, so which tasks need to be done. And I kind of think of two main sources for this. The first is maintenance requests or breakdown reports. Basically, this is somebody outside of your maintenance organization telling you that some work needs to be done. And a useful side effect, kind of as a side note here, of the maintenance planning and scheduling process, and of also building the knowledge base you'll build in the process, is that you can then train users of equipment to pay attention to and report things that indicate a likely impending failure. And this could possibly be done as part of a pre or post shift checklist that's then shared with the maintenance function. And so this even helps to optimize the types of maintenance requests we get. We want to try to get exactly the information we need to properly maintain the equipment. And the other place that our work tasks come from are the preventative or routine maintenance schedules. So each asset under your responsibility will have some routine maintenance that needs to be done. A good starting point for this is the manufacturer recommendations, but this will be augmented by your experience. And maybe kind of a bonus source of work tasks is predictive maintenance or operational analytics. So this might be considered a hybrid approach of looking at schedules and requests. In this case, the maintenance item is expected, but it's requested by analysis of the operating conditions. That's how I think of it. Anyway, maybe I'm the only one. So when the criteria for a certain maintenance item is met, the maintenance is scheduled. So example might be if you had a pump, maybe you have sensors on the pump for the pump run time and or the flow rate and or the temperature, and that might be used as a basis to determine that maintenance is needed. And automated analysis can then suggest the maintenance. And this can help you optimize your maintenance spending, but you have to be careful because it only works if the analysis is actually good. All right, now, how should it be done? So how should each task be done? So first thing you need to have is maybe obviously a procedure, step-by-step instructions. And you'll want to build a collection of these and improve them over time. And you want enough detail in the work plan to allow any qualified technician, somebody with the right skills, to accomplish the job. So even if they've never worked on that particular piece of equipment, as long as they have the requisite set of skills, your work plan, your step-by-step procedure will give them the information they need to properly make the maintenance or repair. But then you also want to allow room for experienced, skilled technicians to use their judgment. So if there's multiple ways to possibly accomplish the job, maybe leave that to the judgment of the technician. Although there might be times when you want to specifically override the technician's judgment. For example, if you know there are two possible solutions to a problem and the technician might choose whichever is most convenient at the time under normal circumstances, which is totally fine, you might specify that they choose one over the other, maybe because there's a history of failure of one of the solutions on this particular machine for whatever reason, or maybe there was an agreement between engineering and maintenance function to perform an upgrade at the next maintenance. And so that needs to be done in a certain way. And then you also want to explain the reason so that the technician doesn't use their discretion to override the more specific instructions. And besides this step-by-step work plan, there's some other things that should be included in the planning of the maintenance. And that's things like where's the shutoff valve or circuit breaker or whatever, and how do they lock it out? If there's a key to something, you need to get into a room or a cabinet, who has the key? Who do they need to notify that they're on the premises or shutting something down or otherwise starting to work? So there's some security or operations personnel or a supervisor or manager they need to let know before they touch something or get into something. What hazards do they need to be aware of? So they're confined spaces or fall hazards or suffocation hazards or any kind of things that they need to be aware of so they don't get hurt. And, other little things like, is there a chance they'll set off a fire alarm or trip a security measure if they're not aware that there's some kind of sensor or trip mechanism in the area? So basically everything, not only the step-by-step instructions for the actual maintenance task, but everything around that they might need to successfully and safely complete their job with as little hassle as possible. All right, next thing in the planning is, what do they need in order to do it? So maybe the obvious thing here is parts. You need the parts if you're going to replace something or upgrade something or repair something. You need the parts to do that. You also need tools. And if possible, you want to let the technician know exactly which size of which driver or wrench or whatever they're going to need. Do they need a hoist or a jack or some other lifting apparatus? Do they need a ladder? If so, what size and type of ladder do they need? Scaffolding they might need. And you want to specify this and make these items available so that they don't have to be running back and forth to the shop or wherever to gather these things. Once they go there, they see, oh, I'm going to need a ladder. Let me go grab back and get one. Oh, this thing's going to be too heavy. Let me go get some kind of lifting apparatus or whatever. All right, so parts and tools. They're going to need skills. What skills are required to accomplish this task? They're going to need time. How many hours is this job expected to take? And for repeatable tasks, this can be revised, and you can get a very good idea of how long a task takes under certain circumstances. How many people? Can this be done by one person, or do you need multiple people to accomplish this task in the right amount of time? You're going to want to have documentation. They might need some manuals or wiring diagrams or mechanical schematics or other drawings. Permits, so things like hot work permits or confined space permits. They might need some lockout tagout materials, so make sure you specify which type of padlock or breaker lockout mechanism or tag will be compatible with the equipment they're going to need to lock out. There's incidental things like grease and oil and rags and caulk, fasteners. Might need some of those. A vacuum to clean up for some reason. Maybe they need a 50-foot 12-gauge extension cord because the nearest receptacle isn't close, so they got to make sure they have an extension cord of a certain length. You can let them know that. Maybe they need a rope, who knows. And for repeatable tasks, you can be very precise and specific about what will actually be required to accomplish the maintenance task. And then for one-off or otherwise uncommon tasks, you'll have to rely on the experience of the planner and the technician to assemble the tools and materials likely required. All right, now we can get into maintenance scheduling. And this is the when should it be done and who should do it. So when should it be done? That's the calendar schedule. And to consider scheduling, you need to first consider priority. So you want to schedule the higher priority things first. So the higher priority things are going to be things that deal with life safety or structural integrity, and then business impact. So things that will cause a loss of production if they're not done. These are your higher priority tasks. You also need to take to account for the availability of the properly skilled labor to accomplish the task. So you can't schedule more electrician hours in a week than you have electricians. You have to schedule work when the parts are available, and you need to order them first. So we don't want to schedule maintenance until we know we'll have the parts at the time the maintenance is scheduled. Otherwise, we'll have to reschedule it or do something else in that time and adjust the schedule on the fly, which is what we're trying to get away from doing. We also have to account for the ability to plan for the downtime of equipment. So do we need to do this maybe off shift, or do we have a scheduled maintenance window for a particular piece of equipment that has to be accounted for in scheduling of the maintenance? Okay, now when scheduling, you're going to be scheduling your work tasks and assigning your people, and you know how much time each task should take. It's also important then to make sure you leave room in the schedule for reactive work. That's the stuff that comes up and needs to be taken care of right away. Have to have extra hours of slack built into your schedule to account for that. And how much depends on your exact situation. And it's something that hopefully if you get a good maintenance planning and scheduling process going, you'll be able to pretty precisely understand your needs for reactive maintenance versus planned maintenance. And then all of the things that are needed to accomplish the task, the things in the previous section, the tools and the materials and whatever else, should be arranged for ahead of the scheduled time so that your maintenance technician doesn't show up and have to then figure out where everything is, or we don't have that part yet, so I guess you're gonna have to do something else today, or whatever. All right, now we're down to who should do it. Each maintenance task should be performed by someone who actually can carry out the task. Maybe that's pretty obvious. Often it makes sense to have a specific maintenance technician own a certain piece of equipment or an area in order to maximize the benefit of their experience with that particular area or equipment, and also their engagement with the customer, the operations personnel that are operating in that area. And on the other hand, it's also important to make sure that others can complete the tasks if necessary. You want to consider, do we want to outsource this work or do this in-house? So we want to hire a contractor or use one of our employees. Specialized skills or equipment that aren't needed often in your facility, obviously we want to outsource that. Work that requires some certification or license that you don't have would also be outsourced. And then as you get an idea for what type of work and how much of each type of work you have, you can develop the personnel in-house to accomplish the common task and then only outsource the ones that you kind of need to outsource. The person who's going to do the job should be properly trained, so they not only need to have the skills to complete the job, but they also should have the skills to survive the job. So if it's a confined space job, you have to have someone who understands the dangers and how to mitigate the risks of working in a confined space. Same thing with ladder use. You want to make sure that someone who's going to be working on a tall or otherwise dangerous ladder understands how to use that ladder effectively and not get themselves hurt, and all those sorts of things. You want to make sure the person is properly credentialed, right? They have the right license or certification required by any regulatory agency or other authority that you have to answer to. And then you want to also make sure for each task that if it's an important task that can't be deferred till later, that you have a backup person that can accomplish the task if the sort of main person isn't available. And that could be someone in-house, or it could be a contractor you call from outside if necessary. And after the work is done, so we have it planned, we have it scheduled, we have the work done. Now we want to follow up. So the obvious thing we want to do is figure out if the work was actually done. What was the outcome? Was it done to the expected standard? And we also want to know, were there any problems with the procedure or maybe suggested improvements to the procedure? And as part of the process of our planning and scheduling, we can integrate the feedback from the technicians and from the operations people about how the procedure went and what the outcome was in order to improve our procedures so that when we do it next time, we do it better, and we do it the time after that, we do it better. And we can also continuously refine not only the procedures, but the parts and materials list. And doing this, we create a thorough and extremely valuable knowledge base about the maintenance of the things that are under our area of concern. Okay, now who should perform the maintenance planning task? Who should do the planning? Ideally, you would have dedicated planners, people with no other job. And this is a good idea because if you have someone with no other job but the planning, they'll take ownership of the plans, and they'll also get it done because they don't have other responsibilities to take care of. So this kind of proactive planning is the kind of thing that you could easily put off with when more urgent tasks present themselves. And so if you have a dedicated planner, they ideally won't have more urgent tasks than planning, and so they'll actually get the planning done, and we can start to reap the benefits of this type of work. In some cases, it might not be realistic, or it might not seem realistic to have a dedicated planner, but I think in any situation where there's enough work for several maintenance personnel, even a handful of people, the planner will likely be able to pay for themselves in increased efficiency or productivity of the maintenance function. So that's something to consider as well. Even if you think, well, there's really it's not realistic in my business to hire someone or move one of my maintenance people into a dedicated planner position. Consider if it's possible that if your maintenance were better planned, you could gain efficiency that then pays for the work done by the planner. And even in a fairly small operation where we decide a dedicated planner or a dedicated maintenance planner really doesn't make sense, it can still be beneficial. And for the maintenance technicians, and if you're out there and you're some type of maintenance technician and you don't have any kind of planning function helping you get your job done, it's still beneficial to you to plan your own maintenance tasks and keep a record of your plans and your materials lists so that when you're tasked with a job, you'll have exactly what you need to get the job done. It'll be less frustrating for you if you have a plan ahead of time. Maybe that's not the ideal situation, but it's better than not having a plan at all. The planner should be someone who understands the work being done. And it's possible that you might choose the planner from the ranks of experienced technicians, someone who has the experience to understand the work and also maybe has the temperament or other skills to make them a good planner. For example, they should understand the operation of the business, and they should understand things like the costs associated with labor and with materials and with downtime, and basically understand everything around the actual maintenance tasks as well when they're doing the planning and scheduling. Now, another thing that's going to help us maximize the benefit of our maintenance planning and scheduling is coordination with other parts of the business. And go through a few specifics here. The materials management or purchasing or supplies function in your business, however that's taken care of, you as the maintenance department, you want a straightforward way to acquire the parts and materials you need and to make sure you're able to get them to where they need to be when they need to be there. You also want to have some assurance that your suppliers will get paid. Might seem obvious, but it happens that they don't get paid, so that they'll keep shipping parts to you. Because if you don't pay them, they won't ship parts to you. And this is more likely to happen if the purchasing or whatever function understands your process. So they know how you order things, they know who you order from, and so they're more likely to your orders are less likely to get sort of stuck in the bureaucracy because they don't understand what it is that you're ordering, why you're paying all this money for whatever it is. And depending on the nature of your business and your maintenance tasks, you might even be able to outsource your stockroom. Some of the big industrial supply companies will take care of managing and stocking your maintenance inventory for you. And there's pros and cons to this, but it's something to consider. You also want to be able to coordinate with the operations, which is kind of obvious. We kind of talked about this before. The maintenance function is providing an essential service to operations. And so tight coordination between how the business is running and what are the capabilities of the maintenance staff, and when can we take down equipment for maintenance and all that sort of thing. Maybe there's some expansion of operations coming up soon, and so the maintenance function needs to be able to ramp up to be able to handle that expanded workload. Another group to coordinate with is engineering, and in some cases, maintenance and engineering are the same people. There's no difference between the group. But maintenance feedback to engineering can help influence decision making with regard to upgrades or process improvements or whatever. And engineering communication with maintenance can help to ensure that the maintenance function can maintain the proper workforce in the face of, like I talked with operations, in the face of expansion or upgrade or whatever. And then the other group I want to talk about that we want to coordinate with regards to our maintenance function is the management of the business, or the business function. And we want to be able to communicate the success of our maintenance program. We want to share the metrics that we have to justify the budget. And the goal would be to convince them that maintenance can contribute to maximizing profit rather than just being looked at like a lot of businesses look at maintenance as sort of just a black hole of cost. We're just dumping money down there, and it's something we have to do, I guess, but we don't really want to. And a lot of times that mindset gets us to, you ask, hey, can we shut this whatever process down to do some maintenance? And they say, no, we need it. When you shut it down, we lose money, which, okay, that makes sense. That's totally true. When you shut it down, you lose money. But what ends up happening if you operate and maintain your equipment that way is eventually the equipment breaks down and it's shut off and you're losing money. And you can compare sort of on paper, well, what if we run it till it breaks, it fails, and then we have to figure out how to repair it, which might mean we have to order parts that we don't have, which might mean we have to wait for them because they're coming from who knows where, or they don't exist yet and they have to be made for us. And so that's going to have a certain impact versus if we, shut it down at an interim stage and keep it maintained, operate more efficiently, whatever. You get the idea. The idea is that we can demonstrate that proper planning and scheduling of maintenance can actually increase the profitability of the operating equipment. And that's your goal in coordination with the management or the business function in your business. All right, so let's talk about some of those metrics that we can use to first evaluate how we're doing as far as the maintenance planning and scheduling processes go, and then also communicate the success or the progress we're making to the other people who care about this sort of thing. One of the metrics we can use is wrench time, or the ratio of wrench time versus other activities such as gathering parts and looking for documentation and all that stuff, idly waiting around for work, which is another thing that people do if we don't have a good plan and a good schedule. And a good target for this is 60 to 65% of the technician's time being spent actually doing maintenance tasks. The ideal value will really vary based on specific circumstances. So for example, in an organization where all the job happens inside the plant or on a campus, we'll have a higher wrench time percentage than in an organization where work is distributed over a wider geographic area. And also for some maintenance organizations with a more general scope, you'll want the technicians to maybe spend more time gathering their own parts and materials and tools or whatever, while in organizations with a much more specific scope, these things might be organized and staged by the planning or the supply function. And so your optimal wrench time is going to vary depending on the exact circumstances, but it's something that you can start measuring and then see how it improves over time and then figure out where you should be. Another metric is to optimize planned maintenance versus reactive maintenance. So there's certain things that we're going to have to do after things break down. We don't get to them ahead of time. But there's a lot of things that we can do ahead of time. And a number a lot of people throw around for this is we want to have 80% planned maintenance versus 20% reactive maintenance. Again, this varies depending on the exact circumstances of your business. But again, it's something you can measure. We also want to optimize unplanned downtime, or maybe more importantly, unplanned downtime that impacts production. Ideally, you have the machines or the equipment only down when you meant for them to be down and never down otherwise. But we can start for this year we had so many hours of unplanned downtime. Next year, see how we do the year after that, and try to get to the point where you have as little unplanned downtime as possible. And the value of this can be quantified, if you can communicate with the operations people, what is the actual cost of downtime, say during a production shift? What is that cost? So how much money did we save by, say, cutting unplanned downtime in half? What was the actual dollar value of doing that by having an effective maintenance plan and an effective maintenance schedule? Another metric a lot of people like is the maintenance backlog. And people kind of use the word differently. The backlog might be work with a date in the past, so work that missed its date. Or some people would say that a backlog is just work that hasn't been done yet, either because it's late or because it hasn't been scheduled. And what makes sense depends on how you schedule your work, how you decide on what work needs to be done. You could also look at the total backlog. You could look at backlog for a specific craft or a trade. That would help you decide if you need more or fewer of a particular trade. You could look at backlog of work that affects life safety or structural integrity, so that high priority work, make sure that work is getting done. You want to make that backlog as close to zero as possible. You can also look at your preventative maintenance backlog, so missed or late or skipped preventative maintenance, and those are the kind of things that you know that you can get away with, not adding grease for a certain amount of time, but if you let that ride too long, you're definitely going to have a failure. And then another kind of way to look at downtime and failure is to talk about, before I was talking about, say number of hours of downtime in a year. Another way to look at that is the time between failures, or the time between loss of production. And also you can quantify that by actually defining what is the cost of the lost production. So you track these things, you can use them to both improve your process, your planning and scheduling process, or even just see how you're doing. And you can also use these things to communicate to the people who make decisions with the money and who care about the actual functioning of the business, that your program is doing what it should be doing. And if it's not, you can use the numbers to explain how you can improve them and make the maintenance function do what it's supposed to be doing for the business. All right, so that's about all I have to say on this topic right now. If you have any questions about this, or comments or suggestions for other topics, you can contact me by email at podcast@facilityscience.com. And I hope this was useful to you. So thanks for listening.